Today we are going to be factoring trinomials in the form of x squared plus a bx term, just as we had before, and it could be a minus bx term as well. So the b just stands for any coefficient, for instance, this in letter B here, 3 could be the number here. But the difference between yesterday and what we did today is that we will have a minus sign in front of the c. So that means c is less than 0. And so what we're going to end up having to do different is, instead of the outside-inside terms adding to make the middle term, the b term, they're going to end up subtracting. And so basically, when we take a look at our problem here, like x squared minus 2x minus 15, this minus sign in front of the 15, the way they got that was because we had opposite signs. So rather than having the same sign, now we have opposite signs as the sign for the last terms in each of the binomials. So we draw our two sets of parentheses, and we can always start with x and x in these problems because the first two numbers have to multiply to make x squared. So what we do is we think of the numbers that multiply to make 15. For instance, 3 times 5 makes 15. We also have 1 times 15. Those will also multiply to make 15. But we want to pick the ones that will end up not adding but subtracting to make 2. So when we take a look at the 3 and the 5, see, those multiply to make 15, but those will subtract to make 2. See, if we take this 5x here, and the inner terms are 3x, when we subtract those two numbers, we do get 2x. Now, I want to make sure it's a negative 2x. So what that tells me is that the 5 needs to be negative, the 3 needs to be positive. So I'm going to put the plus sign with the 3, the minus sign with the 5. You see, those will end up subtracting to make a negative 2x. Notice how we had opposite signs here. One's minus, one's plus, and they have to be that way, so they multiply to make that negative 15, which they do. So there's our answer. So again, it doesn't matter the order that you put it in. X plus 3 times by an x minus 5 is the same as x minus 5 times by x plus 3. So let's take a look at the next one here. Here we have the same situation. We have that minus sign in front of the last term. So whenever you see that, right away, instead of the same sign, we're going to end up having opposite signs. So opposite signs is what we're dealing with. So that tells us that one's a minus, one's a plus inside the two binomials. But I wouldn't put those first. I'd put those last, because we want to make sure we get the signs correct so we get the right sign for what the outer and inner terms combine to make. In this case, a positive 3. So I start with x and x, because those numbers multiply to make x squared, and then I start to think of the numbers that multiply to make 10. See, here I've got 2 and 5, those multiply to make 10. I also have 1 and 10, those multiply to make 10. So I just try a set. Let's try the 2 and the 5. So I know 2 times 5 makes 10, but we still need to check the outside terms, which make 5x, and the inside terms, which make 2x, and since they have the same variable raised to the same power, we're going to end up combining them. And if I do subtract, because they are opposite in sign, I will get a 3x. Now I want a positive 3x. So what that tells me this time is I need more positives than negatives. So I needed to have a negative 2 to take away from the positive 5s to make a positive 3. So in order to do that, I need to put the minus sign with the 2, the plus sign with the 5. And you see how negative 2 times 5 will end up making that negative 10. So there's our answer. And again, it doesn't matter which order you put it in. X minus 2 times by the x plus 5 is the same as x plus 5 times by the x minus 2. Well, let's take a look at the next one here. Here we have a negative 16. So again, when you see that negative sign in front of those terms, you're always thinking of opposite signs. So let's go ahead and try doing this problem here. We're drawing two sets of parentheses, putting the x on the outside, and we go ahead and think of the numbers that multiply to make 16. Well, we've got 4 and 4, we've got 2 and 8, and we got 1 and 16. So pretty soon you'll get really good at these, and you'll be able to just look at the numbers and think to yourself and do some steps in your head. Well, remember, these numbers that multiply to make 16, when we take a look at their outside terms, multiplying the x by one of those two numbers And then the inner terms, multiplying one of the numbers by x, we need them to subtract to make 6. So I know 4 minus 4 doesn't make 6. I know 1 minus 16 doesn't make 6. But I do know 2 minus 8. I can get a 6 from that if I take the difference of those two numbers. So let's put those in there. See, 2 times 8 makes 16. And when I take a look at the inside terms, I get 2x. The outside, I get 8x. And you see, those will end up subtracting to make 6x. Now, I don't want just a positive 6x. I want a negative 6x. So in order to get that to be negative, it tells me I need more negatives than I need positives. So I'll put the plus sign with the 2, the minus sign with the 8. And that will end up working out. And you see how 2 times negative 8 will. We end up with that negative 16. So there it is. Again, it doesn't matter which order you put it in. X plus 2 times by, and x minus 8 is exactly the same as x minus 8 times x plus 2. Because of what property? The commutative property allows us to switch the order of the factors and get the same answer. Let's take a look at the next one. A little tougher problem here because we have a bigger number, more factors of 72 than there are of 10, 16, or 15. So, but we look at the sign in front, and that sign in front tells us that we're dealing with opposite signs. Opposite signs. So opposite signs, when we're talking about adding or subtracting, we're thinking of subtraction because opposite signs tell me to subtract. Same signs tell me to add. So I draw in the two sets of parentheses. I've got x and x making x squared. Now we've got to start thinking about those factors of 72. Most people think of 8 times by 9. But as you think about that, remember, opposite signs, that means to subtract. And those don't subtract to make 6, so I know that's not right. So then you try to come up with another one. And let's say you're stuck. I just don't know any more factors. Well, here's what you can do. Take that 8 and that 9 again and break those numbers down. Break it down to like 3 times by 3. Break the 8 down to 4 times by 2. You can even break the 4 down further, but you might be able to get away with it like this. Now let's regroup some of these numbers. We can regroup it in a number of different ways. We could do this right here. 2 and 3 make 6. And then I could take these two numbers. 4 and this 3 right here make 12. That means that 6 times by 12 also makes the 72. I could have grouped it a different way. I could have grouped all of these numbers. The 2, 3, and 3. See those numbers? 2 times 3 makes 6 times 3 makes 18. And then I'm just left with that 4. So 4 times by 18 is another way to come up with factors of 72. So those are all different ways. I could even go another way. I could just do 3 here and hold on to that 3 and then just multiply these numbers right here. See, 3 and 2 makes 6 times by that 4 makes 24. So that's another set of numbers that multiply to make 72. And I could have always done 1 and 72 itself. So different ways to multiply to come up with the same value. And so again, a lot of people get stuck on factors because you just can't think of what goes into that number. We'll break the numbers down to not even the prime factor form, just a factored form, and regroup the numbers. So let's take a look at what we've got. We've got this 6 and 12. See, I know those multiply to make 72 because the factors make 72, but do they subtract to make 6? Oh, yeah, they do. See, I could do that subtraction in my head. 12 minus 6 is 6. Let's put those numbers in there. See, the outside terms make a 12x, inside make a 6x, and I can subtract those to get a 6x. Now, if I subtract to make 6, that means I want positive 12 and a negative 6. And those numbers will end up multiplying to make a negative 72, but subtract to make a positive 6. So those are our answers. So we got x minus 6 and an x plus 12. Well, next problem is similar, not as tough because 60 doesn't have as many factors, but let's see what we've got. We've got this minus sign in front of the 60, so again, that tells us that we're dealing with opposite signs. And when we deal with opposite signs, that means that we are subtracting the outside and inside terms. So as we draw those two sets of parentheses, we start to think of numbers that multiply to make 60. X and x already go in for x squared. Those are the only numbers that work. So as I do that, first numbers that come to my mind are 6 and 10. But when I think about that, those aren't the right numbers because they don't subtract to make 7. So let's take that same concept and break the numbers down. Let's break the 6 down to 3 times by 2. Let's break the 10 down to 5 times by 2. And let's reorder the numbers. Here we've got we already did 3 times by 10, so let's take the 3, the 2, and the 5. See, that multiplies to make 30 times by 2. Well, 30 times by 2 doesn't quite work because those don't subtract to make 7, so I know that's not right. So let's regroup it a different way. Let's regroup it maybe how about the 2, the 5, and the 2? See, those multiply to make 20. 2 and 5 make 10 times 2 makes 20. And I've got that 3 left over. Well, that makes 60, but they don't subtract to make 7. So what that tells me is I need to get the numbers closer together. So let's try multiplying the 2 and the 2. See, 2 times by 2 makes 4. So I took this 2 and this 2 here. Now I'm going to take this 3 and this 5 and group those numbers together. That makes 15. Ooh, that makes 60. Now, do those subtract to make 7, though? Well, let's see here. 4 minus 15, that makes 11. Not quite the right number there. So we've got another way we've got to try this one out. Let's go ahead and regroup it again. So we can do another set, which would be this 3 and the 2. And we've already multiplied the 3 and the 2 by the 5. So let's do the 3, the 2, and the 2. So 3 times 2 makes 6 times 2 makes 12. And then we also have what's left over, the 5. So I had to regroup it a bunch of different ways until I figured it out. And you see, the 4 and 15 almost worked, but didn't quite work. But this one here, 12 times 5 makes 60, and they subtract to make 7, so it works. So let's go ahead and put those numbers in there, 12 and 5, and let's go ahead and try this. 5x, this makes 12x, and we do get those to subtract to make 7x. So when I get the 7x, now I just want to make sure I have a negative. So I need more negatives than I need positives. So that's why I have the 12 as a negative and the 5 as a positive. And that will make a negative 7x. So there it is. We've got our answer. We've got an x minus 12 times by an x plus 5. Well, let's take a look at the last one. This one's a little different. What's different about this problem? Hopefully you saw it's right here. This sign is not a negative, it's a positive. That means we have the same sign. So this is similar to what we did yesterday. Here we just have the same exact sign because they have to multiply to make a positive. And that makes the problem easier because now we know outer and inner are adding together to make a negative 11x. What that means is both signs are negative. So the nice thing about having the same sign is we can figure out what that sign is. We don't have to wait until the end of the problem like we did on the last 5 problems. Well, so here we know it's both negative. We know this time they add to make 11. So we're thinking differently now. Thinking of numbers adding. So let's take those factors of 18. We got 1 and 18. Do those add to make 11? I know they multiply to make 18, but they don't add to make 11. So let's try the next. How about 2 and 9? Do those add to make 11? Yes, they do. They add to make 11. So let's put them in there. 2 and 9. So this makes a negative 9x. This makes a negative 2x. And sure enough, those add to make a negative 11x. It works. It works. And so we've got the answer. So on the problems that have the minus sign in front of the last term, we think of subtraction of the outside-inside terms. But the sign, when it's positive, like it was in this last one, that means we got to think of adding the outer and inner terms together. Well, those are the types of problems you're going to end up seeing. Good luck on tonight's homework.